Humans have always wondered if they could get up and admire the stars above them. But the earth have us prisoners for a long time, until we built skyscrapers to try to touch the sky itself. But even that wasn't enough. We want more. So we built giant vehicles to free ourselves from our gravitational prison for our little planet, leaving behind what we know, and began the exploration of the vastness of space, until our little planet becomes a little blue speck of dust suspended in the darkness, while our species expands the scientific and technological horizons and the universe mysteries will be uncovered. But first, we need to know how these vehicles operate and a little bit of the physical concepts behind them. The general public use the word rocket science to describe something that's incredibly difficult. But yeah, rocket science is difficult, but the engineering part, that's the nightmare. But the physical phenomenon, and the main physical phenomenon, is really simple. The main physical phenomenon is the third law of Newton. For every action, there's an equal and opposite reaction. Literally the rocket just expels mass really fast to the back to accelerate to the front. Literally it's just that. To get that high velocity mass, he uses chemical reactions to accelerate the fuel. But there is a little problem. Like always. You need a really high velocity to get to orbit. You need fuel to move the first fuel, and the fuel that moves the first fuel. Eventually you get 95% of the rocket is completely fuel, and the 5% remaining is just the cargo, the payload that is going to deliver. That's the tyranny of the rocket equation. That is described like the dry mass divided by the wet mass, or in other terms, the mass of the vehicle without fuel divided by the mass of the vehicle with fuel is the same as E, a constant, elevated to the final velocity divided by the velocity of the exhaust, the velocity of the fuel. And you think, oh, just go up 10 kilometers. That is the according height that space began. But yeah, you can do that, but you will come back later. If you want to stay in space, you need to go sideways really fast. From low Earth orbit, 400 kilometers, that velocity is 7 kilometers per second, or 25,200 kilometers per hour. In total, the change of velocity is around from getting out of the atmosphere and getting enough speed to not fall down is around 9.4 kilometers per second. 33,800 kilometers per hour. And that's the velocity you need to change to stay in space. Or, like rocket scientists tell, the delta V, the change in velocity. And the delta V is really how much do you need to get to a place, or how much work you can do with your rocket, because you can calculate it. If we compare rockets to cars, it's like how much kilometers your car with your fuel tank and the efficiency of the tank of the engine can go. And to close up, I'm going to talk about some of the newest and most popular rockets that are in operation or have been. Well, the smallest orbital class rocket that we know is the Electron rocket, made by Rocket Lab, US company, but launches of New Zealand. It can deliver 3,000 kilograms to low Earth orbit, around 200-400 kilometers. The rocket itself is 17 meters in length, 1.2 meters in diameter, and the mass is 13 tons. In comparison, the Falcon 9, that is the most popular inactive, can deliver 22.8 tons to low Earth orbit, has a length of 70 meters, a diameter of 3.66 meters, and has a mass of 564 tons. So compare that. The proportions are huge. And to get a sense of scale, the most powerful rocket until today that had flown, the Saturn V, that get humans to the moon and back, could deliver 118 tons to low Earth orbit and had a length of 111 meters and a diameter of 10 meters. And the mass, 2,800 tons. That's big. Literally, it's just a building, a massive building, with the explosion behind. Control explosion behind. And that's a little rundown. There are a lot of concepts, like efficiency, type of engines, type of fuel, different, not chemicals, mass reactive engines, some concepts that are hilarious that they thought. So maybe I will do a mini series about this, about a rundown of all concepts. Thanks for listening. Goodbye.